Okay, so this is the concept that most people said they were having trouble with, and most meaning, I don't know, maybe 7 people out of the class. And this is almost identical to your homework assignment. I tweaked the numbers, so I want you to understand this, so at the very least you can recreate it on your homework. First of all, this thing has a real name, but I'm calling it MiniDiffys. Okay, so the real name is up there if you care. So you're given a differential equation, and what it means by differential equation is you have y prime and y double prime and y are part of the question that you're trying to find an answer to. You want to find a function y of this form. It's actually just a parabola. So when you take a couple derivatives and put everything back together, it all works out. Okay? And so it seemed like people didn't have any trouble with this part of the process, this taking the derivatives process. And I don't think many people had trouble plugging it back in. So we have 2a minus 2ax plus b minus 4ax squared plus bx plus c equals 3x squared. Okay, I think the next step is what started confusing people. And what I mean by is, having taught this before, that's usually where people get lost. So let me just take the steps a little more slowly and explain them. Hopefully that will unstick you guys. Okay, so expand all that. And what's going to happen now is, since I'm on a computer, I can just make a copy of this. And I'll just make another copy of the same thing. What I'm going to do is, on the left-hand side, I'm going to rearrange the terms differently than they are up above. There's going to be an x squared piece and an x piece, and then all the leftover pieces. Okay, so I've already taken care of this piece, the 3x squared on the right-hand side. So I want to take care of anything that has an x squared in it. Aha, here's a piece with an x squared in it, so I'm going to put minus 4a over here. So the underline means I've already accounted for that piece. Now it looks like I have one x, but I'm going to be putting things in here, so the x doesn't mean anything yet, and those parentheses don't mean anything yet. So I'm just picking up some pieces here. Here's a 2a. It doesn't have an x in it, so it goes over here. Minus 2ax, well, it has an x in it, so minus 2a goes over here. Minus b can go over here. Let's see, I haven't used the minus 4bx yet. Minus 4bx can go over here. And minus 4c can go over here. I've now simply rearranged all the pieces on the left-hand side, but it's all the same values. But now I have a polynomial. And you know what, I'm going to just rewrite the right-hand side to stress a point too. I'm going to say it's x squared times something plus x times something plus something. Then 3x squared is just 3 and 0 and 0. Okay, I don't need this piece anymore, so I've already used it. Sorry about that. So now what? So the deal is, in order for these two guys to be the same everywhere at any possible x value, then this piece has to be the same, and this piece has to be the same. And especially, even if you don't believe me yet, you have to believe me that these two pieces have to be the same, because I could just let x equal 0, and if I just let x equal 0, what happens? Okay, if I let x equal 0, all this disappears and all this disappears. And so it's clear that 2a minus b minus 4c has to equal 0 if these two, if all this is true for any value of x, it has to be true for 0. And by the same logic, it has to be true if x equals 1, and it has to be true if x equals 2. And you can sometimes the way some people solve these is they let x equal 0, let x equals 1, let x equal 2, and so forth, and they use the resultant things that pop out, and they solve for a, b, and c that way. I prefer this. I think it makes more intuitive sense that we are just simply saying this has to equal 0, this has to equal 0, and this has to equal 3. Those are equal signs, but they're sideways. Alright, so if minus 4a equals 3, then what does that mean? It means a is equal to minus 3 over 4. And you would think that this would be very difficult to solve for, but it daisy chains very nicely. So this a is already, we already know a is negative 3/4. So if minus 2a minus 4b equals 0, then we can just pop the a directly in here, alright, and solve. So we have 4b over here. Let's see, we have 3 over 2 is 4b. So b is equal to 3 over 8. Right, and then we need to find c. So we have 2a minus b minus 4c equals 0. So it looks like a mess, but it's really not that bad because we actually have a and b already, right? So let's say I don't like fractions because I hate fractions. We all do, right? I'm going to just multiply everything by 8. And by multiplying everything by 8, I get an extra 2 here. Get rid of the 8. Multiply by 8 in here. And so then I'm going to get 3 times 4 is 12. 2c equals 0. Negative 15 equals 32c. So minus 15 over 32 equals c. Okay. And what good does that do? Well, it solves our problem, right? Because what we wanted was a, b, and c. Sorry about that. That keeps showing up. It's from the last video. Okay, so this gives us a solution. Y equals a x plus b. Sorry, ax squared plus bx plus c. Okay, so what I wanted to do is show you how to do this with Wolfram Alpha so you can check your work. I did talk about this in class, but I couldn't show you very well. Okay, so you type that in, and it's probably going to solve it for me. If it doesn't, I can say solve. It automatically knew that I wanted to solve it. How about that? Okay, so I just look at Wolfram Alpha and I say, oh no! Let me see, can I expand my screen there so you can see that? Alright, so this is what Wolfram Alpha is telling me, and you can see that we agree right here with the ax squared plus bx plus c, but Wolfram Alpha has this other stuff going on. So am I lying to you? No, I'm not lying to you. So what's going on is all this stuff I said non-homogeneous is the non-homogeneous part, which is not part of this lesson. But I just wanted to tell you that if you go back here and you let the constants be 0, then that's one instance of a solution. I mean, so this whole thing works, but we can just can those two terms and the thing still works. It's totally fine without those pieces. And yeah, so this is all good, and yeah, that's hopefully you should be able to do your homework now.